And moving on to question 2. The cyanate ion and the fulminate ion share the same 3 atoms but have vastly different properties. The cyanate ion is stable, while the fulminate ion is unstable and forms explosive compounds. Draw the Lewis structure for the fulminate ion, including possible resonance forms, and use formal charge to explain why the fulminate ion is less stable and therefore more reactive than the cyanate ion. Okay, so let's first start off by writing the Lewis structures for both the cyanate and the fulminate ion. So if we were to calculate the total valence electrons for both of these, since they have the same atoms and the same charge, oxygen contains 6 valence electrons, carbon has 4, nitrogen has 5, and because there's a negative charge, we add an extra electron to our count, so we have 16 electrons in total. So now let's do the cyanate ion first, which is OCN-. So this tells us that our carbon is our central atom, and I'll also draw the different resonance structures that can take place. So first, we can have a single bonded oxygen. Really, I'll draw it like this. And a triple bonded nitrogen. And the formal charges would be -1 for the oxygen and 0 for the carbon and the nitrogen. We could also have a double bonded oxygen and a double bonded nitrogen. This time our oxygen is neutral, carbon is neutral, and our nitrogen would have the -1 charge. And then lastly, we could have a triple bonded oxygen and a single bonded nitrogen. And if we were to calculate all the formal charges for the atoms, this oxygen will have a +1 charge, carbon is still neutral, and this time our nitrogen has a -2 charge. But out of all of these structures, our first one is the preferred Lewis structure. Preferred has 2 R's. Oh, 1 F and 2 R's, I think. Since our negative charge is on the more electronegative atom, which is oxygen. Okay, so now let's look at the different Lewis structures of the fulminate ion. So this time we have nitrogen as our central atom. So this means that we can have carbon, nitrogen, and then a triple bond to oxygen. And this carbon would have 3 lone pairs. So if we were to calculate the formal charges for each of these ions, the carbon would have a -3 charge. This nitrogen would be +1, and the oxygen would also be +1. And that's how it has its -1 charge. Next, we could have double bonds all around. And in the formal charges would be -2 for carbon, +1 for nitrogen, and then 0 for our oxygen. And then lastly, we could have a triple bond in between carbon and nitrogen, and just a single bond to the oxygen. And this time our carbon has a -1 charge, nitrogen is +1, and our oxygen is -1. Okay, so let me just add a note here that the different resonance structures for cyanate have the least number of formal charges than the fulminate ion. So this is the reason why fulminate is less stable. Okay, so now let's see what the junior tutor said. Okay, so they just denoted what all of their terms mean, and they calculated formal charge. It looks like the structure should be here, but they're not. But let me just look at their formal charges. They have -1, 0, and 0 for what I'm assuming is cyanate. And then 0, 0, -1. And then +1, 0, and -2. And then I'm assuming this is for the fulminate now. -3, +1, +1, -2, +1, 0, and then -1, +1, and -1. The overall formal charge for all the structures is -1, which is consistent with the ion's charge. Since the cyanate has a lower magnitude of formal charge values than the fulminate, it is more stable. So all of the formal charges are correct. And the explanation is correct as well. However, the Lewis structures are not shown. So maybe it's like a technical difficulty, but I'm just going to say this solution is incorrect just so that we can see what the issue is. But it looks like they really labeled which structure is which and showed all the different formal charges, but we just can't see the Lewis structures for some reason.